All right, we're back. We're hoping to close out page 175 right now. We are still dealing with hyperbolas, and we want to go from the general equation to the standard equation and then list everything. How can I tell this is a hyperbola, though? Good question. So when you have this form, what you want to do is you want to see how many squared terms there are, what are the coefficients, and what are the signs between them. So in this form, for example, I can tell that there are two squared terms. There's an x squared and a y squared. So I know that I'm dealing with either a circle, an ellipse, or a hyperbola. As soon as I see the minus in front of one of the squared terms, it'll actually always be the y term, because what you can do is you can always multiply through by a negative. It'll just change the signs along the way. So it's always going to be y in general form. What might happen is they might like switch as you do the work. We'll see, potentially that happens. Two squared terms and a minus, hyperbola, guaranteed. Two squared terms and a plus, it's either a circle or an ellipse. If it's the same coefficient, if this was like 49x squared plus 49y squared, that's a circle. If it's 49x squared plus not 49, some other number, y squared, it's an ellipse. So you can actually tell from general form what you're gonna get. The only like caveat to that is if you're in a class where sometimes you run into the degenerate cases, that's like a wild card. Like you just don't know that like you're gonna do all the work, and instead of getting a circle, you're gonna get like equals 0. And then it's like, oh, there's only one point that satisfies it, so it's a point. Kind of a trick question, but in general, you should be able to tell, you know, if things are nice, you can tell what kind of thing you're getting. Like here, I know I'm getting a hyperbola because two squareds and a minus. So now let's actually do the problem. So we got to complete the square a bunch. X squared plus 2x space. Now this is where you could screw up accidentally. I mean, no one screws up intentionally, I guess. But you can screw up because you're taking negative 16 out. So this is going to be negative 6y. And what you can do, and then negative 689. The other day, I don't know how long ago it was for you watching the videos, I like brought a 22 over, but I didn't subtract 22. I just moved positive 22, messed up the whole thing. It was terrible. So I've been avoiding that since then. You should always like learn from your mistakes. That's the best part about making them, is that you can, you know, not make them again. So, and this is, you know, this is a low, we're all friends here. This is a low stress environment. Like no one's gonna hurt you if you make a mistake. No one's yelling. Divide by 2, square it. So that's like plus 1. So I really added 49 times 1. So over here, I'm gonna do plus 49, which takes me to negative 640. I don't know if that's useful yet. And then here, I'm gonna divide by 2. That's negative 3, square it. So I'm gonna do plus 9. But really on this side, I did negative 16 times 9. Negative 16 times 9 is negative 4 squared times 3 squared. 4 times 3 is 12, so it's negative 12 squared. So we really subtracted 144. So I'm going to subtract 144 over here. Minus 144. So now I was at negative 640. Oh man, now what am I at? Negative 784 or something, I think. And is that 16 times 49? That would be the dream. We'll find out. So 49, do x plus 1 squared minus 16, y minus 3 squared equals, yeah, I think that this is, so negative, if I combine these, I get negative 640. And then if I combine these, negative 640, negative 784. Negative 784. Okay, 49 times 16 is actually, what is that? That's like 49, 7 squared times 4 squared is 28 squared. Do I have 28 squared memorized? No, but I bet it's 784. 28 squared. It's like I should have that memorized. My life would be 1% better if I had 1%. No way. Like one millionth of a percent probably. Anyway, it's 784. I just checked it on the calculator while I was babbling there. So now what we're going to do though is divide through by a negative. So what's going to happen is this is going to become x plus 1 squared over negative 16. And then I'm dividing by a negative, so negative over negative is going to become positive y minus 3 squared over 49 equals 1. So that's not really standard form. Standard form, I have to flip them so that the positive goes first. So 1, our equation is going to be y minus 3 squared over 49 minus x plus 1 squared over 16. I'm pretty sure there's a video in the like alternative playlist of how you can use your calculator to go from like the general form to this form. You should definitely watch that and try it out because it's incredibly helpful for like checking your work. So here I want to avoid the mistake, right? So always x goes with h, y goes with k. So it's going to be negative 1, 3. Vertices, so negative 1 and then 3 plus or minus 7. Covertices. My covertices go second. Covertices are kind of like an afterthought for hyperbola. They shouldn't be. You know, they're just as valid as anything else. But foci, got to do some work because I don't know what c is. So c squared, a squared plus b squared because it's a hyperbola. If it was an ellipse, this would be a minus. And nope, no. If it's an ellipse, this would be a plus, this would be a minus. Sometimes it's hard to get your brain to say something different from what you're looking at. So c squared is 59 radical 65. What are you doing? 65. 56, ridiculous. Radical 65. Okay, so negative 1, comma 3 plus or minus radical 65. And then maybe close a parenthesis there. 6, eccentricity is going to be c, radical 65, over a, which is 7. That's bigger than 1, so that's encouraging. And then asymptotes, going to be change this to a 0, change this to an equal, bring this across, 49 over 16, square root plus or minus 7 over 4. So y minus 3 is plus or minus 7/4 x plus 1. There you go, 7 things. Nice. All right, let's try the next one. How bad is this going to be? Not that bad. My guess, so 7, 7 would be like 49 plus like not enough. So I'm thinking this is 8. I'm sorry, like I'm looking at this to decide like what do I multiply this by to get this? I think it's got to be 8, right? 8 puts me at like 56, and then you add another like 16, 56, and then you add 6. It's got to be 8. I'm gonna go with it. Should I check that? Probably. I mean, I'm still gonna. Oh, I'm not just gonna go with it. I want to though. 5832 divided by 729. What did I even type? 58. I'm glad you're not seeing that. I don't even know. Yeah, it's 8. All right, here we go. Let's do this. So 100 x squared minus 12x minus 729. It's like these numbers are so bad that if they're not integers, like what have I done to myself? And it's like it used to be that I was just doing it to my students. Then COVID hit and I started recording all the videos, and now I'm doing it to myself, and it's not great. Negative 12 divided by 2 is negative 6 squared is plus 36. So over here, we really added 3,600. That's big. And then here, divide negative 8 by 2, you get negative 4 squared, so plus 16. Oh my gosh. But really, it's negative 729 times 16. So I'm just going to write minus 729 times 16. I'm definitely using a calculator for that because I don't want to like spend all day here, you know? 8388 plus 3600 minus 729 times 16. I got 324. 324. Oh, not integers. Yuck. 324. Oh, maybe no, it won't be. Okay, so let me keep going here. So that's 10. Nope, 100. X minus 6 squared minus 729 y minus 4 squared equals 324. All right, fantastic. I'm gonna like use the calculator again. So I'm gonna do 100 divided by 324, 25 over 81. So 25 x minus 6 squared over 81 minus, I mean, I don't think this is gonna simplify, but 729 over 324 does 9/4. What the heck? 9 y minus 4 squared over 4 equals 1. Okay, so I could say that's my equation, and that would like totally be fine. But what I'm going to do instead is when I write the equation, I'm going to invert so that it's a little easier to find a and b. So my equation, I'm going to say is x minus 6 squared over 81 over 25. So all I did was invert the fraction, but now I can see that a is going to be 9/5. So it's just, it makes things a little easier. And then y minus 4 squared. I'm not looking forward to trying to find c, by the way. 4/9 equals 1. So that's my equation. The center, x goes with h, y goes with k, so 6, 4. Vertices, so I'm at 6, and I can go plus or minus 9/5. And then 4 stays the same. So it's eating the x-axis, if you like. 4 covertices. So it's 6, and then we're at 4, and we can go plus or minus 2/3. Foci, I'm gonna use a calculator again. In the interest of time, it's like, I don't know if you've ever watched like a replay of a sporting event, like late at night. Sometimes when I can't sleep, I'll watch like on ESPN or whatever, or on TNT. Usually I watch basketball. They'll just be like, in the interest of time, we've skipped over some stuff or whatever. And what we're skipping over, well, not really, because I'm talking through it, is me finding c. So I need to do 81 over 25 plus 4 over 9. So that, and then square root of that, is radical 829 over 15. Radical 829 over 15. So I guess I'll write c squared is a squared plus b squared. So c is radical 829 over 15, which means that finding the eccentricity also not going to be super fun. So the foci, so you are at 6, and you can go c in either direction. 829 over 15, comma 4. Eccentricity is c over a. You better believe I'm going to use a calculator on that. Actually, it's probably not that hard, but I've already decided to do this. 9/5. Radical 829 over 27. How does that make sense? Oh yeah, because there's like 3's involved? No, because of 5 and 3's. Why do you make sense? I don't know. 1/3, and then that. Oh, 27. What is wrong with me? Yes, that makes sense to me. I'm gonna write c over a and say it's radical 829 over 20. Maybe I've made too many videos today. It's always a possibility. 7. Can you tell? You might be able to tell, not really, but you can kind of tell from the shirt that I'm wearing how many videos I've made in a given day, except sometimes I switch midday, and sometimes I wear the same shirt. I usually have washed it, but let's be honest, not always, day to day. So you never know, but it's a good guess. Ooh, this is gonna be tough. So I need to change this to 0, which makes this an equal sign. I'm gonna bring this across. So I have 4 over 9 over 81 over 25. That seems like a job for a calculator. So I have 4 over 9 over 81 over 25. Okay, then I need to square root that. Plus or minus 10/7 is gonna be the slope. So this will be y, ooh, what are you doing? Y minus 4 is plus or minus 10 over 27, which is pretty nice. I mean, it's like, you wouldn't want to graph that by hand, but like, we're not graphing it, we're just listing it. So not bad. All right. So I don't know, do I want to check any of this? I really don't want to, but like we could. So for example, let's go over to the calculator. And let's take a look at which one. I feel like the second one is the harder one. So let's complete square on that. You know what, let's not. Let's do something even weirder. Let's add a graph. So I'm gonna add a graph page. I'm gonna press menu. I'm not 100% committed to this, so I might drop out of doing this halfway through. Conic, general conic. So I'm gonna put in a general conic here. 100 goes with that. 0 goes with xy. Minus 729 goes with y squared. Minus 1200 goes with x. Minus 5832 goes with y. And then our constant term is minus 8388. And then by default, it's equal to 0. So I'm gonna press enter and graphs it. All right, so what can we get from the graph? Let's do menu, option 6, option 9. Let's find the center. So click, and it's 6, -4. 6, -4. What? Why did I get that wrong? Oh my gosh. Let's go back. I got that wrong. Good job, me. All right, but I see why. And so we're gonna fix it because there's 0% chance I'm redoing this video. So let's see. It's supposed to be 6, -4. This is not the worst problem in the world. The problem is here. I factored -729 out of -5832, and I made it negative, but it should have been positive. So what are we gonna do? We're gonna change this to a plus. We're gonna change this to a plus. We're gonna change all of them to a plus, 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 and then down here, it's not as bad as it could be because of the way we write our answers. All we gotta do is throw in negatives. Ugh, so disappointing though. Here, but I mean, that's why we check, right? We check so that we can see that I am wrong. All right, let's go back and see what other trouble we end up with here. All right, so we have that 6, -4. I'm gonna go back, menu, 6, 9, vertices. All right, so the problem with this is that it simplifies them, and so I'm not like 100% sure if I got them. Let's see, it's not gonna be able, I think, to simplify the foci though, so let's do that. Menu 6, 9, on the foci. I mean, I could obviously check some of this on a calculator. So the foci are right, which to me means that we must have gotten the vertices right, because you can't get the foci right without having A correct. So I think we probably got that. Eccentricity it can also find, so let's do that. That'll tell us if it's like further proof because you get like C and A. Radical 829/27. Yeah, this is looking good. I think we're probably right about everything other than what I got completely and totally wrong. So let me go back. I did mention that I might be getting everything wrong. So that was like, I wonder if I like subconsciously knew that was about to happen. I don't know. Anyway, I'm hoping that I got the other problem right. I'm not really sure. If I were gonna check anything, I guess I would check the eccentricity and see if I got that right. Should I do that? All right, you talked me into it. We're gonna check the eccentricity, but the problem is when it's wrong, it's gonna hurt so bad. Let's add a graph page, do the same thing. Menu, option 3, we're gonna change it to equation template and then conic, and then we type it in. So it's 49 and then minus 16, nope, 0, no XY term, minus 16, 98 goes there, that's not a 98, 98 goes there, 96 goes there, 689 goes there, and there's already a 0 filled in. So I'm gonna check the eccentricity. Whew, fingers are really crossed on this because I really don't want to get it wrong. Radical 65/7. So to me, that means I'm probably right. The only other thing, well, not only, you can check anything, but I'm gonna check the center because that's what I definitely got wrong last time. -1, 3, that's what I got, nice. All right, so back to the notes because I always end the videos on the notes for some reason. Not like there's no compelling reason other than, I don't know, I did it once, so I'm doing it all the time. There we go, we're done with the page. Tons of examples. Problem sets, I think there are more examples. The internet almost certainly has a bajillion examples. Just search for, I don't know, like general form of conic practice, and it'll probably give you a lot of them. Calculator can check them. So I'm going to end this here, and I will see you in the next one where I think we're still talking about hyperbolas. I don't know. I'll find out when you find out. So see you there.